All right, we are almost down to our last video here. So we are back to this solve and sort. What I'm going to use instead of those individual little pieces of paper, because this will just show up much better on my screen, is now that we have solved or figured out how we're going to solve these, and remember this little sticky note, I kept this in handy for those that I'm going to factor so it saves me time on my X's, is we're just going to start practicing solving all the different problems that could show up on the Showcase of Learning number 6. So I've got this page, mine's green, and you don't have to have this paper, you can just put on your own random piece of paper. And we are going to take a look and put all the categoric problems that we needed: zero product property, factoring, and then we've got our other page which has the other two options. So let's get started. So we're going to start again with the zero product property, and just a reminder of why we're going to be doing the zero product property on this problem and on this problem is because it's already in factored form. Our goal is, if it's not in factored form, to get it into factored form, but these are already there. So I'm just going to be taking these two problems, and actually three problems, and I'll put them in here. So I'll just start with this top one. And so I'm going to write the problem just so I can keep track of my work. And now that, again, since it's in factored form, I can just set each factor equal to 0. And a reminder of why we're not going to set 2 equal to 0 is because 2 can never become 0. So 2 is a set number. That factor is set in stone as 2. But this factor could become any number I want it to be, because I can pick a number for x. What I'm focused on is what number, if I put it in for x, will make those parentheses 0. And the same for this other factor. So here, to solve for x, I'm just going to simply subtract 7. And so one of my two solutions is 7. And in this problem, I would add 2. And so my second solution is 2. So I'm going to cross these off as I work through them. So down in the middle was this problem. So I'm going to add this into my list. Just space them really far apart. And this problem is just like the other one, so it should go pretty quickly. I don't need to worry about 2. Nothing is going to make this factor become 0. So I just want to know what can make this factor become 0 and what can make this factor become 0. So here I would just add 5 over. So there's one of my two solutions, and in this problem I would subtract 1 over, so my other second solution is -1. All right, my last problem is going to be the toughest of my zero product property already in factored form, so I'm going to write this one down. And now I'm going to set this factor equal to 0. And this factor equal to 0, and I'm going to start to solve for x. So my first step is going to be subtract 1. So I'm still left with 3x on the left side, but on the right side I got a -1. And now to solve for x, I'll divide by 3 and divide by 3 here. So one of my two solutions is -1/3. And in this problem, I'm going to add the 7. So I'm left with 2x on the left side and a +7 on the right side. And now I'll move the 2 by dividing it. So my second solution is the fraction 7/2. So those are all the zero product property. And again, the reason why I could do that is because they were all in factored form. All right, so now what we're going to look at is which ones were we able to factor and then do the zero product property. So those are any of the problems that have an F. So this one and this one and this one. And I did keep my sticky note of all those X's, so that won't take me as long. So I'll be putting this problem first. And so just a reminder, if it is in factored form, your goal is to factor it, because factoring is the fastest way to solve it. So I'm looking on my sticky note, and we decided it was this x. We said, what were the factors of -8? That got us to 7, and those numbers were 1 and 8, with the 1 being negative. And so just a reminder that that's what I had right there. All right, so I'm going to make my parentheses, drop those x's in, but hopefully you realize that the x's won't be enough because x times x doesn't make 2x squared, it just makes x squared. So I'm going to put a 2 with one of those. You could put a 1 there, but I would keep it invisible instead. And now we're going to draw our loops because our loops are going to help us make these numbers. And since x can make either of these, we'll have to start with 2. And 2 can only make 8. So 2 times, following the loop, a positive 4 makes the 8. And that means x times what makes negative 1x, and that'll be a negative 1. Now that's in factored form, we can do just what we did at the top. Set each factor equal to 0. I'm going to speed up my work here for because we kind of did more detail up there. So this is our easier one. Just to get x alone, I subtract 4. So my answer is negative 4. And then in this problem, to get x alone, first I would add 1. So this is what I meant. I'm not going to show all those little steps. And now to solve for x, I'm going to divide by 2 here, which leaves it as x. And when I divide by 2, it becomes 1 divided by 2. So those are those two answers. All right, another problem that we could factor was this problem. And it was equaling 108, but we had subtracted the 108 over. So just showing you what it looked like. So now this problem does have a GCF. So I'm going to take that 2 out, and this is what we did before. So that gives me 54. And now my x is going to be a lot easier because of this. And we've already made that x. It was here. Factors of negative 54 that get me to 3. Factors of negative 4 that get me to 3. And we had chosen the numbers 9 and negative 6. And now the 2 is just coming along and making my factor parentheses, dropping those x's in, and x are enough. That makes the x squared. So I can use this x, because they're both x's, to make 9x, so that would be a positive 9. And I can use this x, it should have looped here, not there, to make a negative 6x. Now that it's in factored form, remember this factor will always stay 2. Nothing can make it 0. So what can make this factor 0? What can make this factor 0? And for here, I would just add 6 over. So one of my 2 solutions is 6, and I could subtract 9 over, and one of my 2 solutions is negative 9. All right, we've got one more factoring problem that was in our, right? Yeah. Let's see, which one do I still need? Yeah, one more problem. So the last problem looked like this. So notice it did not start in standard form. So what we had done is we had added the 10 over. And when you add the 10 over, this becomes 0. And when you add 10 to this number, it became 2x squared minus 7x minus 3. Now that it's in standard form and it equals 0, I'm ready to factor. So I'll rewrite it here. And again, just to remind you, I have already made the x. Okay. It was this one. So factors of negative 6 that get us to negative 7. So again, just a reminder, I've already done this. It was a negative 1x and a negative 6x, making my factor parentheses and dropping those x's in. And like the first one, x and x are not enough because I need 2x squared, so I'll put a 2 with one of these. And I'm going to draw my loops for these side numbers. And since x can make either, I'll start with the 2, and 2 can make this. So 2 times a negative 3 makes the negative 6x, and x with a negative 1 makes the negative 1x. And now I can set each factor equal to 0. We'll start with our easier one. Here I would just add the 3 over, so one answer is 3. And in this one, I'd add the 1 over. And now I would divide by this 2, so my second answer is 1/2. All right, so everything on this page ended up in standard form. Either it was in standard form or it started in, everything ended up in factored form. And so if it didn't start in factored form, it was in standard form, which we could convert into factored form by factoring. Now, my remaining problems are either depended on the quadratic formula and the square root method. So the quadratic formula is still used in standard form, but it just happens to be a problem that we couldn't factor. So in this, we ended up with 2 of those problems. And again, we will rediscuss the good, better, and best answers. You just need the good answer on the showcase of learning. That will be fine. But here is one problem. And just a reminder of why the factoring didn't work. If I made my x, here it is. It would be this one. There are no factors of 6 that got us to -8. So with that, as a reminder, I'll put that quadratic formula here. And now I'll determine a, b, and c. And a, b, and c are numbers. They will not have the x squared, but it's based off of a, x squared, b, x, and c equaling 0. Excuse me. And so a is the coefficient in front of x squared, b is the coefficient or number in front of x, and c is just the plain number. So I have my invisible 1. This one is -8, and c is 6. Do not put any x's in here. So it goes x equals opposite of b. So I will put 8 plus or minus. Here goes my square root, and now I'm going to take b and square it. When you square a number, you always get a positive. So -8 times -8 is 64. Minus 4 times a times c. And then all of this is over 2a, so 2 times a, 2 times 1 is 2. From there, all of your work will be focusing on the check mark. So notice the things that are staying the same. You can use a calculator and type in without the check mark, without the square root. You would just type in 64 minus 4 times 1 times 6. What that calculator is doing is it's following the order of operations. So it's multiplying first and getting 24, and then 64 take away 24 is a 40. So that's a good answer. We will check to see if we can do a better answer. So is 40 perfect? No, it's not. But maybe there are parts of 40 that are perfect, and so we leave out the 1 in 40. But in all of these numbers, the only number that has a nice square root that's a perfect square is 4. So if you like the good answer, then you don't need this next step. But if you want the better, best answer, you can break this down into square root of 4 and square root of 10. And then the 8 plus or minus over 2 still stays the same. The square root of 4 becomes a 2 with the square root of 10, staying that way. So that's a better answer. And then the best answer is if you can take a triangle, the radical does not get to be a part of the triangle. And what's the greatest common factor? What can you take out of all of those? That would be a 2. So I can divide this by 2 and get 4, plus or minus divide this by 2 and get 1. The 10 stays protected by that check mark, and divide this by 2 over 1. So a good answer, a better answer, and the best answer. And all will be accepted on the showcase of learning. It would be great to try these, but it's okay if you stop here. All right, the other problem that we had to do the quadratic formula on, or there's 2 more actually. I'm not going to have enough room. This one and this one. So I'm going to start with this one. Just a second, I got to get a little more room going here. I wrote too big. So here's 0 equals 3x squared minus 5x plus 3. And just a reminder, it's got to be in standard form and equals 0. All things we had already checked before. But a is 3, b is -5, and c is 3. So now we're going to do x equals opposite of b. You can't see that. Opposite of b. Plus or minus my square root, and now I'm going to take b and square it, so that when you square a number it's always positive. You get positive 25, minus my 4 with my a and with my c, and then all of this is over 2a, so 2 times a is 6. From there, the 5 and plus or minus over 6 just stays that way. Here goes my check mark. And again, you can type this into your calculator, 25 minus 4 times 3 times 3, but order of operations would have you multiply first. So 4 times 3 is 12, and 12 times 3 is 36. Or maybe you want to do 3 times 3 is 9, and 9 times 4 is 36. And then when I have 25 and I take away 36, I get a -11 in here. For the record, we did talk about that. When you take the square root of a negative number, this is technically a non-real answer, and we stop right there. So that's our answer for this problem. And on the last problem that we're going to do, it looks like this. Oops, it's supposed to be 0. And just one more reminder of why that one didn't work. There are no factors of -5 that make -3 if we make our x again. So a is 1, b is -3, c is -5. And now we're going to do x equals, again, opposite of b, so 3 is written down, plus or minus our square root. And then we take b and square it, so -3 and -3 multiplied is 9, minus 4 times a times c, and then all of that's over 2 times a, so a 2. So again, we're going to go back to that check mark and just clean that up. So if I do my multiplication first, 4 times 1 is 4, take that times -5 and you get a -20. Then that subtraction and that negative merge together, so now there's an operation between the two numbers of 9 and 20, and it's 9 plus 20, which is a 29. And this is a good answer. Let's see if we can make it better. So I'm going to go to 29, and that's it. So that means if you can't do this step, you will not do the triangle step. This is the best answer. And just a reminder that there are two answers. So the square root of 29 is not far off from the square root of 25. And the square root of 25 is about 5. So I'm going to cover up the sticky note. Just showed this to you last time. And just so, what if we did put 5? It's not quite 5, but it's close to 5. So if I really want a, closer idea to what my answer is, I could do 3 plus 5, which is 8. And then that 8 divided by 2, one answer is somewhere in the ballpark of 4. And then I could do the minus sign, and 3 take away 5 is -2. And if you take that -2 divided by 2, your other answer is somewhere in the area of -1. Not quite those numbers, but not too far off from them. All right, our last methods are going to be everything that we deemed as the square root method. So I'm going to pick these in a very particular order because some of them, let's see, 2 of them actually have another option that I will share with you. So we're going to start with the problems that don't have any other option with this. So I'm kind of just sticking with this side here. So a reminder of why we're doing the square root method is because when I look at the problem, there's one type of x. And all the other problems that we've done so far had more than one type of x. So that's where there's more than one type. Again, you want to try to factor, but if you can't, then you go to the quadratic formula to get your answers. But when there's one type of x, what you'll simply do in this whole page is just work backwards in those order of operations. And remember, it's in the square root step that you're going to get 2 answers. You're going to get your plus and minus. All right? So let's just start with this problem. So I'll copy it over here. So 0 equals, then I got my parentheses. All right, my goal is start to getting this x alone. So the first thing I want to move is addition subtraction. So this is in parentheses x minus 4 squared plus 10. So there's a -4 and a +10. The only thing I'm going to move now is the 10 because the -4 is in those parentheses. So I'm going to start by moving the 10. I'll do that through subtraction. Those cancel out. On this side I have -10, and on the right side I have an x minus 4 squared. Now notice in that x minus 4 squared I never said anything about multiplying or dividing, so I don't have to do this step. Instead, because I have an exponent, I will square root, and this is where I start to get my 2 answers. So I'm going to square root this side, and I'm going to square root this side. It's not the problem I would really prefer to start with. And that squared and that square root cancel each other out, so I get x minus 4. When you take the square root, this is where you're going to get your 2 answers. So I'm going to have a positive and a negative version of the square root of -10. Now I realize you cannot take the square root of a negative number, but let's say it wasn't a negative number. My goal would still be to get this x alone. So what's going to happen is I've got 2 problems. I've got x minus 4 with this positive version, and then I have x minus 4 with this negative version of my square root number. And in this case, I'd add 4. So I'll have that square root of negative 10 adding 4. And in this case, I'll also add 4, but it's a negative square root of negative 10 adding 4. And if you don't want to write it like that, you could write it once. Put the positive and the negative square root of 10 at, or negative 10 at the end, and then put the positive 4 at the end. It doesn't really matter which option you choose as far as that goes. All right, that problem's done. Technically, this is a non-real solution because there is the square root of a negative number, and that won't be happening on the capstone. It just happens to happen here. All right. The next problem I want to do is this one. So, all right. And again, I'm doing this because when I look at the problem, I see one type of x. So the first thing I'm going to move, well, I have x plus 3 squared minus 5. So I did say some addition and subtraction, but this won't happen till the end. That's my parentheses. So I'm going to move this 5 over by adding it. I'm going to not show as much work here, so that gives me a positive 5. With x plus 3 squared, there is no multiplication or division, so we're going to go straight to undoing the exponent with that square root. So I'm going to square root this side and square root this side. And just like before, that squared root and that squared cancel each other out, so I get an x plus 3. But also when I square root here, that's where I get my two answers, a positive and negative. So I'm going to have positive and negative of whatever the square root of 5 is. So from here, again, I have two problems. I have x plus 3 equaling the positive square root of 5, and I have x plus 3 equaling the negative version of whatever the square root of 5 is. And that's like 2 point something. In either case, I'm going to subtract 3. So when I subtract 3 here, I'd subtract 3. And these are not like terms, so I'll just leave it like that. And then I can subtract 3 here, which makes it gone, and I can subtract it here. If you do like this idea of one answer, you would write it as the radical going last, the positive and the negative version of that, and then a negative 3 combining with that. That's supposed to be a negative 3. All right, let's take a look at another problem. And I think this next one I'm going to change on us. So, hopefully you're watching this video, and we are not going to make this a negative. We are going to make this a positive, because I'm a little tired of some of the numbers that are popping up. All right, so from here, crossing off some ones I didn't cross off, I'm going to write this down. Draw my wall, and this is 2 times x plus 3 squared minus 4. So again, with that addition subtraction, this addition's in the parentheses, so it will go at the end. So I'm going to move this minus 4. I'm going to add 4, makes it go away, add 4 here, and we get a 4 with this. And then to get x alone, this is 2 times x plus 3 squared. I do have multiplication here, so I'm going to divide by 2 and divide by 2, which leaves me with 2 there. And now I'll undo this exponent by square rooting. So I'm going to square root this side, and I'm going to square root this side, and the square root and the squared cancel each other out, so I'm just left with x plus 3. And when I square root over here, I'll get a positive version of the square root of 2, and I'll get a negative version of the square root of 2. And those signs, the positive and the negative, stay outside the square root of 2. And now I'll deal with the parentheses, but this is where I'm going to have two problems. I'm going to have x plus 3 with the positive version of the square root of 2, and I'm going to have x plus 3 with the negative version of it. Either way, to get x alone, I'm just going to subtract 3. So when I do that, it's the square root of 2 minus 3. These are not alike. I cannot combine them. And here when I subtract 2, it's the negative version subtracting 3. And again, you can write them separate. If you want to write them once, just remember that square root of 2 goes last, and there's a positive and a negative version. And then this minus 3 we'll treat as a negative 3 combining with that. Okay? And again, you could always type in negative 3 plus square root of 2 and see what you get. This is like 1 point something, so I just don't know exactly what it is off the top of my head. All right, the last two problems I want to go over with you, I'm actually going to put on a separate piece of paper because these stand out a little differently. So the last two problems I have set for the square root method because there's one type of x in the problem. There is always an exception to most things that we do, and maybe some of you will realize that this was actually a problem that was in a difference of squares. So you can factor this or you can isolate x. So let's say you just want to isolate x. So I'd add 49 here and be left with x squared, and that means I would add 49 here and get 49. And now to isolate x, I'll undo that square by square rooting both sides. And when I square root the squared, they cancel out and I'm just left with x. And when you take the square root of 49, you actually get a nice number 7. But this is where you get a positive and a negative version. So that's one way to get our two answers. Otherwise, some of you might realize that it's a difference of squares of x plus 7 and x minus 7. And then when I set my factors equal to 0, I'll subtract 7 here, get negative 7. And I'd add 7 here and get a positive 7. So either way, you're getting a positive and negative 7. This problem is also a difference of squares if you do a GCF first. But let's say you don't see that. So first, I'd add 8 over here, so it's a positive 8 here and still 2x squared. So after my addition subtraction, I move my 2 times x squared. I move my 2, I divide by 2, and I divide by 2, so I get 4. And now to get rid of the squared, I square root. The square and the square root cancel out, and I'm just left with x, and then the square root of 4, this is where I get my positive and negative 2. Now, if you notice that you can factor it, first there is a GCF that you can take out, and then this is our difference of squares of x plus 2, x minus 2, and now that it's in factored form, you can set each factor equal to 0. Here I'd subtract 2, so I get a negative 2, and here I would add 2, and I get a positive 2. So either way, you're getting a positive and negative 2. And those are the problems. So the next practice that you're going to be having will be a review for a showcase of learning.